everybody. Today we're going to be doing our last day of notes, Unit 7, Day 4. We're going to do rotations and dilations, which are the last two transformations that we need to work on. So let's go ahead and get started. So rotation is a transformation that turns a figure around a fixed point. Most likely, I'm pretty sure this is the only time you're going to see it, is we're going to end up rotating an entire graph, so we're going to rotate around the origin. So the entire coordinate plane gets moved around. I keep making motions with my hands, so if you get a little lost in this, we will go over this in class, not to worry. But yeah, it's just basically we're rotating the entire graph to see where the image lands. And there's two ways we can rotate it. We can rotate it clockwise, which is turning it to the right, like how a clock moves, or counterclockwise, which is turning it to the left, in the opposite directions of a clock. Okay? So I wanted to start off by showing you how these rotations are. So we rotate these by degrees, which basically means, like, you guys have all heard of like a 360 turn, like they did a 360 thing in extreme mountain bike. I don't know what it's like. The Olympics, snowboarding. They did like a 360 turn or a 90-degree turn or 180. Those are all turns. Okay, so I want to show you what they look like going both clockwise and counterclockwise. So here's a graph. So I've already put all the rotations and the pictures on here. I'm just going to show you what degree. So this is where we're starting at on both these counter and clockwise. So this would be a 0-degree rotation, or if we did a full rotation all the way back to its starting point, that's 360 degrees. Okay? So if they want you to move it 360 degrees, it's basically going to end up in the same location. Just like if you turned all the way around, you do a 360-degree turn, you end up where you started. Okay? 0 degrees just means we haven't moved. All right? Then for clockwise, if we go ahead and turn it to the right, the whole graph, flip the whole graph to the right this way, the triangle looks like it moved to quadrant 4. That's a 90-degree turn. So if you think of each quadrant like it's a turn, like each quadrant is like 90 degrees. So for the clockwise, it would go from quadrant 1 to 4. Counterclockwise, we move it to the left, so we're moving it this way, it goes from 1 to 2. Okay? Then a 180-degree turn means we went 2 quadrants to the left or right. So if we started in 1, for clockwise, we're moving down 2. For counterclockwise, I just did the wrong way. Clockwise means we're moving to the right. So we move this way, just like the hands on a clock. And then for counterclockwise, we move the other way. Okay? With 180, whether we're going counterclockwise or clockwise, you're ending up in the same location. If you look at these two graphs, they're identical. Okay? And then the last one is 270, which means you go 3 quadrants. So if we started in 1, and we're going clockwise to the right, we went 1, 2, 3. Okay? Counterclockwise, we started in 1, 1, 2, 3. Okay? So those are the different movements. Alright? Now, there is a cheat sheet for rotations. Rather than trying to move your graph, which is really hard on a computer screen, because you can't pick up the computer and you can't hold anything up to your screen. So the cheat sheet is using the points. Okay? So here's the rule. If you're moving clockwise 90 degrees, which is actually the same thing as moving counterclockwise 270, you end up in the same quadrant. The rule is just to flip the numbers around and make whatever x was a negative. So you just change the sign of 1, and it does matter which one, but flip the numbers around so the x becomes the y and the y becomes the x. Okay, with 180 for either one, it just means you're changing the sign for both. And then for 270 for clockwise, but 90 degrees counterclockwise, same thing again. We flip the x and y again, but this time we're going to change the y to be negative. So if you can memorize these rules, it's going to save you so much time and effort. Because otherwise what you could do is just redraw the image on graph paper or a whiteboard and then physically rotate it yourself to see where it ends up and then draw that new image. Okay? By the way, I think I've already mentioned this. A pre-image is before a rotation and an image is after a rotation. So, example, rotate this 180 degrees clockwise. Well, if I look up in my handy dandy chart, 180 degrees clockwise means just change the sign. So we're going to use this one, this rule, if I can click it. Alright, so that means I'm going to go ahead and record all of these points. By the way, if it's not labeled, I strongly suggest you label each of these corners. Now, it doesn't have to be the same number that I did. No. All we're doing is just kind of like organizing these little corners so that when we redraw it, we can redraw it, basically, in the correct shape. So, I just labeled it this way. You can copy it down, but you'll probably have to label it yourself on other ones. But yeah, so A is at -5, -1, B is -5, -3, C is at -3, -3, D, which is that inner corner, -3, -2, E, -1, -2, F, -1, -1. So all I'm doing, because I'm following this rule, is changing the signs of the X and Y's in all of these points. So the new A prime, which is what this little thingy means again, remember? That little like accent mark or apostrophe. A prime is 5, 1. B becomes B prime, which is 5, 3. C becomes C prime, 3, 3. D becomes D prime, 3, 2. E becomes E prime, 1, 2. And F becomes F prime, 1, 1. Okay? So, and then once we have those, we can just go ahead and replot them on the coordinate plane, which means they're all going to be quadrant 1 now. And then we just draw it. That's our new image. Okay? Which looks like if I turn the graph, that's where this guy would end up right here in that shadow part. Okay? So you guys are going to try this one on your own, and I believe, nope, just that one. I only gave you one. Cool. So, and it says to rotate 90 degrees counterclockwise, so use your notes, label it, get it done, and we will go over, I'll show you what the picture looks like once you rotate it in class. Alright, the second part of our notes is dilations. A dilation changes the size of a figure by either enlarging it or decreasing it, but it's like a scale model of it. So if we enlarge it, it's going to be the same dimensions, just like different lengths. But we use a scale factor. So this goes back to like similar figures. So, but to do this, we just multiply each coordinate of the vertices by the scale factor. So we basically just find the corners and then multiply the X and Y by whatever the scale factor is. Plot the new vertices and connect them just like we do. So I'm not sure what happened to the image that was on here, but this basically, if there was a picture, it walks you through. So step 1 would be to write down all your corners. So they already did that. And then this problem said it was increasing by a scale factor of 2. Don't worry about the through the origin stuff. It's all going to be through the origin. So basically we're multiplying each of these X and Y's here by 2 to get our new points. So we do that. We get, these are our new points. We plot them and we connect them the way that the shape is supposed to be. Okay? And it's not this little dog thing, don't worry. So, you guys have to try on your own. All you're doing, writing down what A, B, C, D is, multiplying it by whatever the scale factor is, and then getting the new points, redrawing the image. That's it. Okay? So, now this one does have a scale factor, that's supposed to say factor, not figure, of 1/2, which means you're going to have to multiply by 1/2. Okay, so give that a try. We will go over what these look like next class. And if you have any questions, write them down. Otherwise, I will see you then. Bye. Bye.